you turn to page 185. And we're going to take out our highlighters. And the next thing we're going to look at is how do you solve a quadratic equation? And a quadratic equation contains a quadratic, and you're like, well, what the heck is a quadratic? A quadratic is any second degree term. So if you have something, a variable that is squared, that makes it a quadratic equation. If the highest value is the x squared, it's a quadratic equation. Grade 9 and grade 10, you solved mainly linear equations, right? If I gave you x plus 5 equals 9, anybody know what x is? If I said x plus 5 equals 9, x would be 4. Linear equations are pretty easy to solve in our head. But if I gave you a quadratic equation, x squared minus 5x equals 6. Any guesses that would work?
X could be 1.
X could be 1.
No,
close. Oh. 1 is close. Any values of x that work?
2.
2. 4 minus 10.
No,
No. So close. So it takes a while, right? Guessing and checking might take a while. 6 works. 36 minus 30, see that it would be 6? Negative 1 works. Negative 1 squared is positive 1. Negative 5 times negative 1 is positive 5. 1 plus 5 would be 6. Now, we're going to learn that guessing and checking is not so easy. However, and I showed you this a little bit already, but I'll show it to you again. If we can take what we have and make it equal to 0, and change it from adding and subtracting to multiplying. When you multiply two things and make them equal to 0, it's very powerful. If two numbers equal 0 and they're multiplied together, one of them has to be 0. There's no other way, there's no other two numbers you could pick, multiply them together, and get 0. This is so important. We take out our highlighter. We call this the zero product property. So if I factor this to be x minus 6, x plus 1, I've now changed it from adding to multiplying. And if I split it here where the multiplication is, if it multiplies to equal 0, that means one of these has to be 0. Well, if the first one is 0, if x minus 6 is 0, what could x possibly be to make that 0? 6. And if the second one is 0, what could x possibly be to make that 0? Negative 1. And those are the two solutions that make it equal to 0. Or make the original equation equal to 6. But it only works if you're multiplying and it's equal to 0. And that's called the zero product property. So with that, we can go to example 1. I'll put this up on YouTube and you can see it later. So part A, it's equal to 0, but we're adding and subtracting. Could you possibly factor this? Now, the first one's an x squared. That's super easy. You see, your only choice is x and x for your first ones. Last one is a negative 56. So let's just think about 56. Is there any two numbers that multiply to 56 if you add or subtract? You get 1. Gotta know your times tables. 7 and 8. Now, if I put 7 and 8, I need a plus 1. Does it make sense that I would make my outside plus 8 and my inside minus 7? Double check. Is my last one still negative 56? Because sometimes you find an outside and inside that work, but when you double check it, it's actually a little bit off. But in this case, it does. So this means, okay, I'm now multiplying, right? If Factoring means this is this times this. I'm now multiplying, so I can use that zero product property. The first one. If this is equal to 0, what could x be? 7. If this one's equal to 0, what could x be? -8. If you double check, what's 7 squared? 49. Plus 7, 56. Minus 56, 0. Perfect. Double check the -8. -8 squared is positive 64. Plus a -8 would get you to 56. Minus 56 is 0. We get 2 answers. So what's the problem in part B? It's already multiplying. And it's not equal to 0. It's equal to 22. Someone says, well, why can't we do 22? I said, well, what multiplies to get you 22? Well, it could be 1 and 22. 11 and 2. 3 and 22 thirds. 1.735 and a number to be named later if I had a calculator. You could have any you pick any number and you could find something that works to make 22. There's an infinite amount of possibilities. This is a problem. So this idea only works if we have equals 0. So we're going to actually have to multiply everything out first. Combine like terms, make one side equal to 0. Now, when multiplying this out, can you see that your first ones make 3x squared? And when multiplying this out, you guys are past grade 10 now. I think you can do the outside, minus 18, and the inside, plus 1, all at the same time. Are you okay if I just write minus 17 by doing those two things at the same time? My outside is negative 18. My inside was plus 1x. Negative 18x plus 1x gives me negative 17x. And my last one's 1 and minus 6. Minus 6 still equal to 22. So if I need it equal to 0, does it make sense we'd have to subtract 22 on both sides? Minus 28. Now for factoring. Okay. Again, used to be in grade 10, whenever you had a number in front of the x squared, you said they were hard. I'm going to say they're not too bad. Because if you think about your first ones, you see you only have one option to get 3x squared. It would have to be 3x and x. And it doesn't matter if you write 3x and x or x and 3x. At this moment, you don't have order yet. But now the last one is going to take a little bit of thinking. Now, if you struggle a little bit with factoring, one of the best strategies is to try something, even if it's wrong. I'm going to start with 1 and 28, which I know is going to be wrong. First of all, if I put the 28 here, it's going to get multiplied by that 3. It's going to be a big number, and then I only subtract 1. Is that going to give me 17? No. So I put 28 here and 1 here. Now my inside would be 28. My outside would be 3, which gives me 25. It doesn't work. So I can already cancel out 28 and 1 are not going to work. But by trying one of them, you'll sort of be like, ooh, I think I can figure it out. Did anybody have some numbers you want me to try? Last ones have to be 28. What multiplies to 28 that you think might work?
7 and 4.
Try 7 and 4. So now you have options, right? It could be 7 and 4. If I put the 7 here and the 4 here, my outside is 12, my inside is 7. 12 and 7 make 17? No. But if I try the 7 here and the 4 here, outside is 21, inside is 4. Is 21 minus 4 equals 17? Yes, I need a negative 17. So does it make sense that I want my outside to be negative 21, inside plus 4 to give me negative 17? Double check. Is the outside, last one still minus 28? Yes. Perfect. So now we can split it, and I'm going to start with the easy one. If the second one, the x minus 7, was 0, right? Because now we can use that zero product property. Factoring changes it to multiplication. Then x would be 7. This one.
Excuse the interruption, all grade 12, please make your way down to the gym, and you are sitting in the mezzanine level. This is for the pep rally. So grade 12 to mezzanine level.
Hey, this is a little bit harder. What if this one is 0? What's x? And you're going to get really good at this. And if you want to, you could show some work. Okay? The answer is going to be -4/3. And you're going to be able to do this in your head really quickly, because what you're actually doing is you're saying, I'm changing the color, I'm writing this small, but you're saying in your head, I want that to equal 0. That's like a grade 9 math question. Could you get x by itself? What would you do first? You would probably subtract 4 on both sides, right? And then to get the x by itself, you would divide by 3. So you have 2 mental math things to do. Move the 4 over and divide by 3. And I think you're going to go directly from here to here and no problem. But right now, you might want to write the green in. I mean, you could have done it here too. Ooh, x minus 7 has to equal 0. What could I possibly do? Move the 7 over, x equals 7. But that one, you saw the mental math right away and could do it very well. But for the first one, we had to do a little bit more work. Okay, questions to circle? 4, 5, 6, and 7.